Hello everyone. So let us look into the next question in projection of planes. We have here in front of us a hexagonal lamina of sides 30 mm is resting with one of its corners on VP and its surface is inclined at an angle of 30 degrees with VP. The diagonal passing through the corner which is in VP is inclined at 45 degrees to HP. Draw the projections of the lamina. Now let us look at the criteria which we are supposed to satisfy to obtain the solution to this problem. So the first criteria is a shape, that is a hexagonal lamina. Second criteria is dimension, which is 30 mm. Third criteria is it is on VP, more specifically resting with one of its corners on VP. The surface is inclined at 30 degrees with VP, and finally the diagonal passing through the corner which is in VP is inclined at 45 degrees to HP. The diagonal is inclined at 45 degrees to HP. So let us get into the solution of the problem now. So the first step being to draw the XY line. Now here we have to draw it in such a way that it is resting on VP, because it is very clearly stating that it is resting with one of its corners on VP. So basically my lamina is going to be on the vertical plane. So far we have been solving problems, most of the problems wherein it is resting on HP. I think one of the problem of rectangular lamina is resting on VP. We have already done that. So similarly here also we will be solving it in such a way that the hexagonal lamina is resting on the vertical plane. Right? So the hexagonal lamina of sides 30 mm. So I shall measure 30 mm using the compass and I'll be drawing a circle of 30 mm. Right? I think some students were asking, sir, are we supposed to erase the circle after you draw the hexagon? You need not have to do that. The circle is the part of the process of drawing the hexagon, so you can leave it as it is. Okay. So now when we draw the hexagon, we'll have to draw it in such a way that it is resting on one of its corners on VP. So I will be drawing a horizontal diameter. Now using the same 30 mm. Using the same 30 mm, from this point I shall draw two arcs. Again from here also I shall draw two arcs. I shall get the points and I'll join all these points with proper visible lines and I'll be able to get our hexagon. Right? So I have drawn the hexagon wherein it is resting on one of its corners, wherein it has two corners on either sides on the vertical plane. So let us start again. So follow the same naming nomenclature. So I have my point A, B, C, D, E and F. Right? So after this, provide the dimensions for this. Show the dimensions for this. So which happens to be 30 mm. Until unless absolutely needed, please do not provide dimensions to our inclined lines. So try to show the dimensions for either to the vertical line or to the horizontal line. Unless we don't have a choice, then you can show the dimensioning line to inclined lines. Okay? Right? So we have a hexagon. So from each of these points, so we have satisfied the criteria over here, wherein the shape, naming and the dimensions are provided. Everything with respect to the first position front view is completed. So let us draw the top view now. So since we are placing flat on the horizontal plane, the vertical plane, so it will be seen as a line from the top view. So I have all my points. It will simply be seen as a straight line along the vertical plane. So I have my point. So yeah, I forgot. So everything which is in the front view, please name it as dash. So A dash, B dash, C dash, D dash, E dash and F dash. So here in the top view I have A, F bracket B, E bracket C, then I have my point D. So everything with respect to the first position is completed. So we have satisfied three criteria: the shape, which is the hexagon, dimension, which is 30 mm, and resting on VP. That part of the criteria we have satisfied. It is resting on the vertical plane, that is, it is touching the XY line. So let us go to the second position. It says that the surface is inclined at an angle of 30 degrees to VP and is resting with one of its corners on the vertical plane. So again here also, as typically seen, opposite to a corner I have another corner, and opposite to an edge we have an edge. This is in case of a hexagon, or this is also observed in case of a square. So here I have a choice: either I can rest it on A dash or I can rest it on D dash. So if you rest it on A dash or if you rest it on D dash, both of them are correct only. So I will rest it on A dash. So resting on A dash, so I will choose an appropriate point. So I have my point A. Now observing in this question, you see that the surface is inclined at 30 degrees with VP. So I shall draw a line inclined at an angle of 30 degrees. So taking it over here, then from there I shall draw a line so 30 degrees. Now measuring this distance from D to A, I shall measure. We do not know what this value is, but D to A, let's assume it as some X value. So I shall measure and cut the arc. I have my point D. Then A to E dash bracket C dash, that also I shall measure. A to E dash bracket C dash, that also I shall measure. And A to F bracket B. Sorry, I am saying dash again. Please ignore that, because in the top we do not have a dash. It is only in the front view. So from A to F bracket B, I shall measure again. I shall cut the arc. So I will get my point F bracket B. So join all these points with a proper visible line, and we shall be satisfying the criteria, that is resting on one of its corners on VP, while the lamina makes an angle of 30 degrees to VP. So from here we shall draw the projection lines and get the front view. A and D dash, A dash and D dash will be in the same straight line, and I have my now looking at the points, I have my point A and A dash over here. So this is my new A dash. B and B dash over here is my new B dash. C and C dash over here is my new C dash. D and D dash over here is my new D dash. E and E dash over here is my new E dash, and finally F and F dash over here is my new F dash. So join all these points with proper visible lines. We shall get our second position front view. right? So here again we have satisfied two more criteria, that is resting on one of its corners, which is my point A, and the lamina is inclined at, the surface is inclined at 30 degrees to VP. Finally, next step is to observe that the diagonal passing through this corner, which is that corner? The corner is A. So I have a diagonal which is my A to D, sorry, A or A dash to D dash. So this particular diagonal is supposed to be inclined at an angle of 45 degrees to HP. So here you observe that this is supposed to be a beta angle problem, wherein a beta angle procedure is done specifically with respect to either the median, altitude or the diagonal. So whenever these three make an angle with respect to VP, then we are supposed to do the beta angle procedure. But then since this is a diagonal and the diagonal is inclined an angle of 45 degrees to HP. So some of you may be thinking, why are we supposed to do the beta angle procedure? So I can clearly state that since the lamina is resting on the vertical plane rather than the horizontal plane, the lamina is resting on the vertical plane, then we will have to do the beta angle procedure over here. Alright. So let us start off again. So I shall call this as, let's say, D1 just for understanding purposes. So it is said that the diagonal is inclined at an angle of 45 degrees to HP. So I shall take a point. Okay. I shall take a point and I'll draw a line inclined at an angle of 45 degrees. Inclined at an angle of 45 degrees, I shall draw a line. Next, I'll be locating a point over here, okay, and I shall call that point as my A dash. I shall call that point as my A dash. Now, coming to the first position, we will be following the same procedure what we have been doing so far for all the beta angle problems. So, what I'll do is from A dash, in the first position, I shall measure from A dash to D dash. I shall measure the distance and cut the arc. I'll get my point D dash, and from D dash, I shall draw a line. I shall draw a line which is parallel to the XY line. This line is supposed to be parallel to the XY line. Now I shall measure from A dash to D1 dash. So this one I have just named it only for our understanding purposes. So you can leave it as it is. But we are supposed to measure from the second position now. From A dash to D1 dash, I'll measure that. I got it here. So this is my D1 dash. So I shall join D1 dash to A dash and I'll extrapolate this line backwards. I shall extrapolate this line backwards. So this becomes my beta angle. So measuring that beta angle, from here I'm measuring, from this particular point I'm measuring the beta angle. So that I'm getting it as 52 degrees. So I'm getting beta angle as 52 degrees. Some of you may be thinking it's supposed to be called as an alpha angle. Yes, it is actually called an alpha angle. So what angle we get in the top view, that is actually called as the beta angle, and what angle we get it in the front view, that is actually called as an alpha angle. But most of the cases we leave it as beta angle itself. We just leave it as beta angle itself. Okay. So getting into the problem now. So we are supposed to be recreating the second position front view in the third position front view. So how can we go about doing that? So I shall measure the distance from A dash to F dash. So this distance is constant. A dash to F dash is from same as A dash to B dash, and same as C dash to D dash or D1 dash, and same as D1 dash to E dash. So I shall measure, I shall cut the arcs first. Next, what I'll do is I'll measure the distance from D1 dash to F dash. From here to here I shall measure. That will be the same as D1 dash to B dash. It will be the same as A dash to E dash, and it is the same as A dash to C dash. So D1 dash till here and here. Next, A dash from here till here and here. So joining all these points, so I have my A dash, next here I have my B dash, C dash, I already have my D1 dash, E dash, and I have my F dash. So join all these points with proper visible lines, we shall get our third position front view. So if you observe very carefully, the opposite edges will always seem parallel to each other. So B dash to C dash will be parallel to F dash to E dash. A dash to F dash will be parallel to C dash to D1 dash. And A dash to B dash will be parallel to E dash and D1 dash. So if it's little offset, you will know that you have gone wrong somewhere. So kindly please be careful. Okay. Next, draw the projection lines and get the front view for this. So I have from A dash. Next I have from B dash, from C dash, D1 dash or D dash, doesn't matter. E dash, and finally F dash. So again from here also we will draw the projection lines and get the top view, the final step in our problem. So I have my A and A dash are meeting here. So this is my new A. Next, right? B and B dash are meeting here. This is my new B. C and C dash are meeting here. This is my new C. D and D dash are meeting here. This is my new D. E and E dash are meeting here. This is my new E. And finally F and F dash are meeting here. This is my new F. Okay. So join all these points with proper visible lines and we shall get our solution. So we have a problem. So solution to this problem. Thank you for your time.